Welcome to the first MBBS student. Myself, Dr. Piyush Makwada. I am Assistant Professor in Department of Physiology, and I am going to take your blood system. So, in this, first of all, we start with the introduction of the blood system. So, in this system, what are the topics that we are going to discuss? So first is the introduction of the blood. Second is the characteristic of the blood. Third is the composition of the blood. Then function of the blood. Introduction of the blood. So blood is a fluid connective tissue which transport the substance from the one part of the body to the another. Red color of the blood, it is due to the presence of hemoglobin. Blood, it provides the nutrients, hormones, enzymes to the tissue and removes the waste products. So without blood, the human life is impossible. What are the characteristics of the blood? So the color of the blood is opaque red. The blood volume is 5 to 6 liter. So 8% of the body weight. 80 ml per kilogram body weight. The specific gravity of the blood is 1.05 1.06. Viscosity of the blood is 4 to 5 times more than the water. The pH is 7.4. Alkaline is neutral. What are the components of the blood? So when we allow to stand the blood, it will separate into two components. First is the plasma, that is fluid portion, and second is cellular elements, that is mainly cell. So plasma, it is a 55%. It is a clear straw colored fluid. It is composed mainly of water. Cellular elements, it is 45%. It mainly includes the RBC, WBC and platelet. So plasma is 55%, WBC is 1%, RBC is 45%. So this flowchart will show the composition of the plasma, that is 55%. Solid is 9% and water is 91%. So the organic molecules 8% and inorganic molecules 1%. So what are the organic molecules? 8% is plasma protein is 7% and other is 1%. So albumin, plasma proteins are the albumin, globulin, fibrinogen and prothrombin. Other are the 1%. NPN substance, non-protein substance like urea, uric acid, creatinine, xanthine, hypoxanthine, sugar, hormones, enzymes and fat. Inorganic molecules are extracellular and intracellular. So extracellular are the sodium, calcium, chloride and bicarbonate. Intracellular are the potassium, magnesium, copper, phosphate and protein. So which are the cellular elements of the blood? So that is RBC, that is red blood cell erythrocyte, WBC, that is leukocyte, and platelets, that is thrombocyte. So first we will see about the RBC, that is red blood cell. So red blood cells are produced in the bone marrow in response to the erythropoietin, that is the protein, okay, which is secreted in the kidney in response to hypoxia. So mature RBC that having no nucleus, and the shape of mature RBC is biconcave shape, and they provide advantage easily oxygen pass to this biconcave shape, pass to the cell membrane of the RBC. Hemoglobin is a protein in the RBC that is essential to the transport of the oxygen. RBC that lie above the 120 days. In RBC, there is a presence of hemoglobin, heme and globin. Average RBC in the adult is 4 to 6 million per cubic mm of blood. The male, the value is 4.6 to 6.4 cubic mm of blood. Female 4.2 to 5.4 cubic mm of blood. When we see under the microscope, the RBC look like this, and it supply the around oxygen to the body. WBC, white blood cell, it is primarily responsible for destroying the foreign substance such as the pathogens, defense mechanism of the body, that appear round and white because they lack the hemoglobin. Normal adult having the 4000 to 11,000 WBCs per cubic mm of blood. Which are the types of WBC? So main types of WBC are granulocytes and agranulocyte. So which are the granulocyte? So neutrophils, eosinophils, basophils, they are the granulocyte, and monocyte and lymphocyte, they are the agranulocyte. So which are the granulocyte? Neutrophils, that most numerous of the all the WBCs, that is main warrior against the infection. Phagocytosis, effective against the acute infection. Basophils, least common granulocyte, assist in the inflammatory process, and it releases the histamine and heparin. Eosinophil, that present in the very small quantity, it ingests and destroys the foreign proteins, secrete the chemicals to destroy the parasites. Increase during the allergy reactions and parasitic infections. So neutrophil increase in the acute infection, eosinophil increase in the allergic reaction, basophils, least common granulocyte, assist in the inflammatory process, release histamine and heparin. Which are the agranulocyte, monocyte and lymphocyte. Monocyte large in the size and primary function is phagocytosis, survive for the several months, effective against the chronic infections. Lymphocyte assists with the immune system, produce the antibodies that destroy the pathogens, help in the control allergy reaction. Quantity of each type of WBC can be determined with the blood test, and is known as differential WBC count. So this slide will show the structure of the neutrophil, eosinophil, basophil, lymphocyte and monocyte. Neutrophil, you can see the 2-lobe to 6-lobe nucleus and fine granules are there. Eosinophil, spectacular shaped nucleus and coarse granular red color. Basophil also bi-lobe nucleus and purple color granules. In lymphocyte, monocyte, they are agranulocyte, there is no any granules, and horseshoe shape or kidney shaped nucleus is present in monocyte. Monocyte is the largest WBC and small lymphocyte is small WBC. Lymphocytes are two types, small and large lymphocyte. Platelets, that is responsible for blood clotting. That smallest of all the cellular components. Normal adult having the 1.5 to 4.5 lakh per cubic millimeter of blood. Average lifespan is 9 to 12 days. Prevent blood loss during injury. So this is the structure of the platelet. Which are the function of the blood? Nutritive function. Carries the nutritive substance like glucose, amino acid, fatty acid, vitamin, electrolytes from the gut to the tissue where they are used for energy. Respiratory function. It carries oxygen from the lungs to the tissue and carbon dioxide from the tissue to the lungs. Excretory function. It carries various metabolic waste products such as urea, uric acid, creatinine to the excretory organs like kidney, skin, intestine, liver for their disposal. Homeostatic function. It plays an important role in maintaining the internal environment of the body. Regulation water balance. Water of the blood is freely interchangeable with the interstitial fluid and help in maintaining the water electrolyte balance of the body. Regulation acid-base balance. Plasma protein and hemoglobin acts as a buffer and help in the regulation of acid-base balance. Regulation of body temperature. High specific heat. Blood has high out specific heat. This heat buffers sudden change in the body temperature. High conductivity help to take out excess heat from the organ to the skin and lungs for dissipation. High latent heat of evaporation. Due to this property, large amount of heat is lost from the body by evaporation of the water from the lung and the skin. Transport function. The various hormones, enzymes, antibodies, drugs transported by the blood to the target tissue. Protective function. It plays an important role in defense mechanism of the body. Neutrophil and monocyte engulf the micro-organism entering the body by phagocytosis. Lymphocyte and plasma globulins are involved in the immune mechanism. Eosinophils are responsible for detoxification and removal of foreign proteins. Some important substances like water, glucose, proteins, electrolytes are stored in the blood and used in emergency situations like starvation, fluid loss, and electrolyte loss. So due to its property of coagulation, it plays an important role during hemorrhage or stop bleeding. That is storage function and role in coagulation. In blood, there is presence of plasma protein, so it is responsible for development of colon-osmotic pressure of the plasma. This pressure helps in the exchange of the fluid between tissue and the blood. They act as a reservoir of the proteins. They combine with the many substances like iron, thyroxine hormones to form the transferrin complex from which the active components are released at that target organs. Serum. If blood is allowed to clot in the tissue, the clot retracts and gives out a serum. So what is serum? It is a plasma minus fibrinogen and clotting factors. Serum has a high serotonin content because of breakdown of the platelets during clotting. So when platelets are breakdown, serotonin is released.